Hello everyone, welcome to Neil Shaw Physics. Today we will be looking at a problem from I.E. Irodov's Problems in General Physics book. This is the first question in the topic of kinematics. The problem reads, a motorboat going downstream overcame a raft at a point A. Tau equals 60 minutes later, it turned back and after some time passed the raft at a distance L is equal to 6.0 kilometers from the point A. Find the flow velocity, assuming the duty of the engine to be constant. Okay, so the first thing to do with these types of problems is to just draw it out. So let's make this point A. Then we're going to have to make a line, and at the end of this line will be when the motorboat turns around, point B. And then let's put a point somewhere in the middle, point C, the point where the motorboat meets the raft again. So let's start with what we know. We know that the distance that the raft goes is a total of L, or 6.0 kilometers. So that's going to be distance AC on this line segment. We also know the distance of line segment AB. Distance is equal to velocity times time. We can define the velocity of the motorboat being v0 plus v, and the time is said to be tau. Now let me explain what each of those variables mean. So let's start with v0. v0 is going to be the flow velocity. So this is going to be the velocity of the raft and just the velocity of the current pushing the motorboat forward. Next, we need to know what v is. V is going to be the velocity of the motorboat if the stream had no current. So if it was just still waters, v is going to be how fast the motorboat would go. So how did I get v0 plus v times tau? So the very basic equation that relates distances with velocities and time is that distance is equal to the product of velocity and time. It is stated in the problem that while moving from point A to B, it takes the motorboat tau minutes to do so. So that means that's the time, but then the velocity is going to be the sum of the velocity of the motorboat if it was in still waters, plus the flow rate, so plus the flow velocity, because that's also going to be pushing and contributing to that motorboat velocity. So when solving these types of problems, you have to think about what way can this be solved. So right now I have two distances, L and v0 plus v times tau. If we got the distance CB, then we can just add up AC and CB, and that's going to be equal to AB. Then that's an equation that we could work with. How do we get the distance CB? So we know distance is equal to velocity times time. So let's start with the velocity. The velocity of the motorboat while it's going from point B to point C is going to be less than when it's going from point A to point B. The reason for that is because when it's going from point B to point C, the current is going against the motorboat. That means the velocity of the motorboat is going to be v minus v0. Now, how much time did it take the motorboat to go from point B to point C? Well, that's not stated in the problem, and all we have is the time it takes for it to go from point A to point B, which doesn't really help us that much. However, we can create a new variable. I'm going to call this variable t total, or the total time it takes the motorboat to go from point A to point B back to point C. From here, to get the time it takes the motorboat to go from point B to point C, you just have to subtract tau, because tau is the time it takes to go from point A to point B. You may have noticed that this is too many variables, so let's try and decrease that and solve for t total. V total is not just the time it takes for the motorboat to go from A to B back to C. It is also the time it takes for the raft to go from A to C. If we rearrange the basic rate of change equation, we get that time is equal to distance divided by velocity. This means that while looking at the raft, we could say that the total time is equal to L, which is the distance it covers, divided by V naught, which is the velocity of the raft. Now I'm just going to make that substitution into our equation for line segment BC. Now we have things expressed in different ways so that when we solve for AC plus BC is equal to AB, we can actually get a useful equation. Putting this together, we get that L plus the quantity V minus V naught times the quantity L over V naught minus tau is all equal to the quantity V naught plus V all times tau. First thing that I will do is just distribute everything and FOIL everything out. Immediately you will notice that a tau V naught is on both sides, so that can just be canceled out. You will also notice that there is a positive tau V and a negative tau V on each side, so those can be combined into like terms. Next, I'm just going to multiply both sides of the equation by V naught just to get rid of that in the denominator, and then I will get this. I didn't even notice that there was a positive and negative L before, so now the positive L V naught and negative L V naught will cancel out. After that, there's only one term on each side, and because there's a V on both sides of the equation can be divided by V, so that will cancel out. And then solving for V naught just by dividing both sides of the equation by 2 tau, you get that V naught is equal to L divided by 2 tau. This is the answer, and if they didn't give any values for L or tau, this would be all you need. However, they did give some values. Tau is equal to 60 minutes and L is equal to 6 kilometers, so we can put that in. So yeah, V naught is equal to 6 kilometers divided by 2 times 60 minutes. This is equal to 0.05 kilometers per minute. That is it for this video. I will be making more videos from this book as well as other physics books if I can. Thank you for watching. I hope you enjoyed. Bye.